All right, everybody, welcome back to another episode of our Algebra 1 virtual tutor. And in today's lesson, we're going to look at Objective 31. Now, Objective 31 will be something that you've actually used quite a bit already this year in the context of solving other problems. But now we're actually going to kind of come full circle with it and talk about solving a system of linear equations. So, what's a system of linear equations? Well, the definition of system is two or more equations that have the same variables. Because we're dealing with linear equations, we're going to have two or more linear equations, which means two or more lines. And then our variables will be x and y because we're dealing with linear equations. To find the solution to this, obviously if our objective is solve, we have to find a solution. And that's found by finding the values of x and y. Again, I'm saying x and y because we're dealing with linear equation, but finding the value of x and y that satisfy each equation at the same time. Now, to solve these, you've got three different options. Each one of these options you could use at any single time. So sometimes you might just learn one way and do it one way. What you use is going to be up to you. I will tell you that certain equations are set up to be solved certain ways. So if you're able to do all three, you can make your life a lot easier by recognizing, oh, I could just do this and solve it real quickly, versus if I do a different way each time. But again, like a lot of math, what direction you use to solve the problem is up to you. The first one, and the one that you'll probably be the most comfortable with because you've actually used it already, is graphing. And what you do to graph is that you have to put them both in slope-intercept form, so they both need to be solved for y, and you find the intersection of the two lines. The reason you've used this already is because our calculator does this for us. You can put both equations, y1, y2, and then do our calculate intersection, first curve, second curve, guess. This could also be done by hand by graphing both lines by hand, but we've used our calculator with this in the past, so this is the one you're going to be most familiar with. Now, elimination actually ends up being the easiest option more times than not. And what elimination does is it actually adds or subtracts both of the equations together so that one of the variables cancels out and we can solve. Substitution is almost the worst method. But it can be used to solve. And what substitution says is you solve one of the variables and then plug the entire equation into the other one. It's probably the most complicated. I would stick with graphing or elimination. You'll use substitution as part of elimination anyway. Now, which one of these options is totally up to you. I'm going to show you one of each, and then when we do a couple of examples, I'm going to do the first one that comes to mind for me. If you want to choose one that you're most comfortable with, that's absolutely fine. All three of these will work on every single problem. It just matters of how much more work you're creating for yourself. Okay, so let's look at by graphing first. And I've got some steps outlined here. But because we're solving by graphing, step one, spell that correctly. Solve them both for y. Now the nice thing is this one's already solved. So I only need to solve this one. And hopefully there's no issues with solving for y, but I will write out the steps for you. Subtract x from both sides. Divide by the y. And make sure we're dividing everything by that value. Excuse me. Make sure our slope is a fraction. And there we go. Now, what I end up with here is two values, two equations, y1 and y2. And what we're going to do in step 2 is graph that. And we're going to graph y1 and y2. But because we're graphing, we're not going to do it by hand. You could graph this by hand, and as long as you were careful and use a piece of graph paper, you could still find exactly what we're going to do. But we are going to use our calculator for the graphing. We have a graphing calculator. We should use it. So, come on. I'm going to type in y1, 3 plus 3x, and y2, negative 1 half. And again, don't worry if your fractions look different than mine. It's going to be the same thing. There we go. And here's the graph. Now, it's important to understand that the solution to the system is the spot where x and y are the same for both lines. So it's right there. To find that, we're going to go to our calculate menu, and we're going to go to intersection. And now we need to be very careful. The first curve, all right, we'll make that our first one. And when I hit enter, watch what happens to my sign. See how it went to the second one there? That's very important. Now you're identifying the second curve or the second line. And what you've done, you've identified the first line and the second line. And now your calculator will calculate the intersection between those two things. But you need to tell the calculator what the two things you're finding the intersection of. Now it says one more time, are you okay with me guessing? That's fine. And right there's our solution. So let's take a little snapshot of that, because I actually did two things in one. But there's my intersection, and that's our step 3. Once we get the graph on there, find the point of intersection. Now, think about that. You could easily do that by hand, put it on a piece of graph paper, use a ruler, and find the point of intersection without using the calculator utility. That'd be fun. So what are my answers here? Well, my answer is actually the coordinate -2, -3, and we can write it like that because it's the point where they two cross. Or sometimes we'll see this as kind of written out separately. Either way is fine. But that's our graphical representation of a system of equations. Find the two lines, find the point where they intersect, because that intersection will be the spot where x and y are the same on both lines. Okay, now let's look at a different way. Now let's do elimination. Now, elimination, our first step is not going to be solve for y. Our first step is actually to identify a variable to eliminate. And it's very important that we do that. And in this problem, right there they are. They need to, the equation needs to be set up, and that probably should have been step 1, that the x's, then y's, and then numbers, these both need to be in standard form. But they were. And your most important thing is identify two variables that are the same. Now, you might have to make them but the same by multiplying one of the equations. But if you end up having to do that, then substitution or graphing is probably a better choice. We want to use elimination when they're obviously the same. Right here, these are obviously the same variables, 3 and 3, 3y, 3y. They need to be different signs. Or they could be the same sign and you would just subtract. In this case, they are different signs. So step 2, combine the equations. And what I mean by that is that we're actually going to take both of these equations and either add or subtract them. And we're going to add or subtract them based on the signs of those y's. So because negative 3 plus 3 will give me 0 y, I'm going to add. If it was 3 minus 3, I'd have to do 0. The rest of these we'll just solve normal. 2 plus 5 is 7. And negative 26 plus negative 23 is going to give me negative 49. Now, that's elimination. They combined, and the whole point is that these eliminated. And I'm left with a simple equation. And the last part of step 2 is combine equations and solve. Because now I can take this equation, divide both sides by 7, and I got, that's actually negative 7. That's tough to see. There you go. And I have half of my answer. Now, where do I get the other half? Well, the other half I'm going to have to do substitution. So I'm going to come all the way back to the original equation, and there's not a good one to pick. So usually I just pick the one that might be easier. This one I can't. So I'm just going to pick the first one, and I'm going to write it out again. But instead of x, I'm going to do a substitution. And now this is an equation that I can solve. Add 14 to both sides. Divide by negative 3. And there's my solution. Now I can write that as the coordinate, like so, or I could write it out however I want. X comma y would be fine as well. Sometimes I'll only ask you for the x value or for the y value and not the entire solution. In that case, you would just put x equals or y equals. Okay, now our third option is substitution. Substitution, I would save for last. It's not one that I often use, hardly at all. But it does come into play when one of the equations is already basically solved. And right there, I see that that equation is basically already solved for a variable. So the first step is to solve one of the equations for one of the variables. And because I can multiply both sides by a negative, then I can change that to positive x. Now, it's in its name that step 2 is going to be substitute. Only, I'm going to substitute this entire expression into the other equation. So I'm going to take this other equation that I haven't messed with, but instead of x, I'm going to substitute in that. So I'm going to take my original equation, but instead of x, I'm going to substitute in. So what happens now? I've got a variable that I can solve for y. So let's distribute. All right, so like so. And we'll have to combine like terms. And let's subtract that 36. And divide by 2. And after all of that, there's my y equals. Now, here's why substitution isn't the greatest thing. We're only halfway done. We have to take that y, and just like we did elimination, we're going to have to substitute again. The nice thing about substitution is that I've already got one of the equations, negative 12 minus 4y. That's, yikes, gee. That's already basically solved. So I can substitute here like so. And then that, I mean, we're pretty much done. 4 times negative 2, I'm going to get 20. So again, I can write that as a coordinate or just a single value. All right. So those are our 3 options: substitution, graphing, or elimination. Again, the choice is really yours on how you go about solving it. But you want to make sure you're comfortable. If you're going to do one way, just be aware. Most people will want to try and gravitate towards the calculator because we want to plug everything in the calculator. That's great, except you're going to have to solve everything for y. If you know a little bit about all 3, you can choose an option that works best always. So let's take a look. And on these 4, what do we got going on? Well, in number 1, I don't see any particular pattern. So on number 1, when in doubt, it's not going to be an elimination because they're not lined up. I guess if my choices are graphing versus substitution, I'm going to go graphing each time. In number 2, again, they're not lined up and there's no variables that are the same, except I do see here that those are the same. So in this one, I would do elimination. On the bottom on number 3, no variables are the same, so I probably gravitate again towards graphing. And on number 4, I do see variables that are the same, so I'm probably going to do elimination. That's your first step. Now, if you want to use graphing for all of them, you'll notice it's not going to be that big of a difference. You will see, and notice here, not once did I really want to use substitution. I find substitution, just me personally, is a lot of extra work. So let's go, and number 1, I decided on graphing. So what we're going to have to do is solve both of these equations for y. So the first one, I'm going to come and I'm going to flip it around. by using our symmetric property. And then I'm going to divide by -4. And there's my first one. My second equation is basically already solved. I am going to flip it around again. And solve it. All right, now that's going to go into my calculator, and I'm going to graph it. But in the interest of well, let's go ahead and do that. I don't want to make things too complicated. So, oops, turn it on here. And I'm going to do negative, and I'm just going to put 0.25. All right, so graphically, it's going to look like this. There's my intersection. Yep, and there's my answer. So let's go ahead and copy that into my problem. There we go. Okay. Now, on number 2, I identified that was going to be done by elimination, which is fine. If I'm going to do elimination, though, I need my variables all lined up. So I don't want to do anything until I have them both in standard form. So in this first one, let's go ahead. I think we'll keep the first one the same. And in the second one, I'm going to move that 3. I'm going to add 3 to both sides. Now I can eliminate. So I'm going to do a big old plus sign because these are the variables, negative y, and you know what? That's going to be a negative sign. There we go. Because negative y minus negative y gives me my 0y. That's what I'm trying to eliminate. Now, some of this will get a little harder. 1/2 minus -3 is positive 3.5. But I don't want it like that, so I'm going to have to actually put it as 7 over 2x. And then over on this other side, -4 minus 3 is just -7. Solve for x, and I get x equals -2. Okay, now I got to take that and plug it back in, and I'm actually going to use this equation right here, and I'm not going to write this out. -3 minus 3 times -2 is -y. So -3 plus 6, so and there's my y value. Again, it's what you're comfortable with. Now, in 3, we agreed I was going to do by graphing. So solve this for y. Let's flip it around. And I'm going to subtract 4. And divide by -2. So there's equation 1. And equation 2, didn't leave myself a whole lot of room here. It's already flipped the right way. Let's subtract 16. And I'm going to divide by -4. There we go. Now, here's something interesting occurred. We haven't run into it yet. What can we tell about those two lines? The answer is that they're parallel. And because those lines are parallel, will they ever have an intersection? The answer is no, they're never going to touch. Which means my answer, just by recognizing that these are parallel, would be no solution. Which, just like linear equations, you can have no solution. Our other one, we can have infinite solutions. Well, what would happen if I had infinite solutions? I'd have actually the exact same line. The lines would be right on top of each other, which is also true. That's allowed to happen. Okay, so you can see that those special things occur as well. I didn't even need to graph it because once I saw that my slopes are the same, I'm good to go. In 4, we want to do 4 with elimination. So I like this first one the way it is. That's fine. And my next one, I'm going to have to move. Really, I'm just going to have to bring the y over to the other side. So there, they're both rearranged. And again, I'm rearranging them in a way that lines up all the variables. And again, just like that other one, this is going to have to be a subtraction sign. So there's my elimination. I'm going to have to subtract 5. And I'm going to get 1 as my answer. And again, we can plug this back in. Again, I got my choice of equations. I guess this one's probably fine. Whoops. Yeah, almost. And there we go. So the choice is yours. If you want to use your calculator for all of them, that's fine. You do have that option. But again, some things are easier with elimination. Above all, it's critical, like on number 3, you understand what those special cases are, where if there are 2 parallel lines, they're never going to touch. Or if they're the same exact equation, they're going to have infinite solutions. All right, that concludes our video for this objective. Again, feel free to rewind at any point, and we'll see you on the next one.